Good morning, everyone. This is Dr. J. Balaji, Associate Professor from Department of Mechanical Engineering, Erode Engineering College. Uh, Engineering Graphics. Engineering graphics is a important subject of all the engineering disciplines because engineering graphics is a common tool to convert or convey the technical information to interrelated departments. Okay, so for example, we design and we develop a new component. For example, I'm saying mechanical, triple E, electronics and instrumentations, or computer science oriented department. We are all put together to effort, give a one common effort to produce a new component. Means we need a diagrammatical evidence. Okay, we need a technical evidence. We need a technical drawing. So that technical drawing we followed to form with a set of rules. Okay, based on the rules only we follow the diagrams. These diagrams will gives some technical inputs to the other department. Then other department will develop the diagram and they are inculcate their concepts on that diagrams. Then it will be transferred into another department. So finally a complete product is before going to be the model, a complete diagram is arrived. Okay, that understanding of diagram, we must need about the knowledge of reading of the diagram scale. Okay, that type of knowledge we acquired from this type of subjects. Okay, so practically it is says this is subject in our day, our system is a practical one. So we need to learn the subject is very important and essential nowadays. So the subject basically a practical one. Okay, so one by one we see the every all the units. So very first unit, plane curves. So what is mean by plane curves? So how the plane curves will formed? Where is the fundamental of plane curves? The fundamentals of plane curves is conic sections. So basics of conic sections. So how the conic sections, what is meant by cone, how the conic sections can be formulated, what are the types of conic sections are available. Ellipse, parabola, hyperbola is the three major important types of conic sections. Following that, the cycloids and then involutes. Okay, so we can see one by one. First of all, cone. So what is meant by cone? Cone is formed when a right angle triangle with an apex and angle theta is rotated about its axis. That means axis is called as the altitude. Altitude is called as height of the cone. Very simple. The diagram is clearly represents the red color cone and the blue color letters or clearly indicates the altitude, the total height of the cone, the vertex point, the or it is called it as apex point. Okay, the vertex point of the cone is a sharp corner, all the connecting edges of the cone. Then axis, the center point of the cone is called it as axis. How this cone can be formed like this? The first question, we have a right angle triangle, a plane figure. Okay, in that right angle triangle we fix a axis. With that axis we rotate the system in 360 degree. Okay, if 360 degree we are rotating that right angle triangle means continuously, that right angle triangle will produces here imaginary cone shape. Okay, can you understand that? The imaginary cone shape. How it will be occurred means the each and every generating points. Okay, wow, the line generating points can be developed point by point, each and every degree movements. Okay, degree 1 to 2, 2 to 3, 3 to 4, each and every degree you consider as a generating points or new generating lines. That generating lines you are have to be assumed it. Okay, I'm saying you have to be assumed it. You assumed each and every degree, single degree point. You yeah, new generating lines. That new generating lines up to 360 degree you consider as this is a cone. Okay, this is what the cone can be developed. Okay, here the length or height of the cone is equal to the altitude of the triangle. How it will be converted? You just look like that. The length or height of the cone is equal to the altitude of the triangle, and the radius of the base of the cone is equal to the base of the triangle. The apex angle of the cone is 2 theta. Already we have a right angle triangle is a single theta, that means the 90 degree. So 2 theta is means the 180 degree. Okay, so totally 360 degree of full rotation. Okay, is complete cone can be formed. This is cone. First of all, we need yeah idea about cone, how the cone can formed. Now I am explained. Next we move on to the sections, conic sections. This is conic sections. So what is meant by conic sections? The section obtained, the sections obtained by the intersection of a right circular cone by a cutting plane, imaginary cutting plane. You give a better word, imaginary cutting plane in different positions are called as conic sections or conics. So see the figure here clearly explained. Very first is circle, ellipse, parabola, hyperbola. There are indicating different colors. Okay, circle can indicate brown, ellipse can indicate blue, parabola indicate yellow, then hyperbola indicate pink color. So each and every curves forms based on a certain conditions, the cutting plane conditions. Okay, so based on the cutting plane conditions only, like this type of curves can be formed through from the conic sections, cones. Okay, okay. We let me see one by one. First, a circle. What is how the circle can be formed? Look at the diagram. So in the diagram, a cutting plane, imaginary cutting plane, is parallel to the base or perpendicular to the axis. Again, I'm telling the cutting plane, imaginary cutting plane passes to parallel to the base of the circle or perpendicular to the axis. Okay, so both the sentence are same, parallel to base or perpendicular to the axis. Then the true shape of the section is called as circle. When we are removing to the top of the cone, then remaining portion will gives as a circle, because the cutting plane passes through perpendicular to the cone axis. That's why we get a one pucka a circle shape. Okay, so in practical case you want to be experienced about this means you have to be make one cone through your ordinary paper. Okay, or make an ordinary paper, you cut like a perpendicular in the section, then you have to be remove it the top portion of the paper cone, then you look out into top area which is definitely formed a circle shape. Okay, so what was the remaining shapes? Ellipse, parabola, hyperbola. Okay. Now here on a practical illustration is given. The practical application of conic curves in a bridge construction. One simple bridge construction can give all the shapes. Okay, here you bridge construction, both the sides are produced hyperbolic curve. Then center part of the bridge is given elliptical curve. Then total arc of the underground, okay, parabolic section. So, without these basic knowledge of ellipse, parabola, hyperbolic curve, we cannot go for understand the bridge construction. So that's why I'm saying already. So engineering graphics is a important one for every the diagram understand purpose. Okay. Okay. Next we move on to the ellipse. Listen everyone. when the cutting plane is inclined to the horizontal plane and perpendicular to the vertical plane. Okay, perpendicular to the vertical. Then the true shape of the section is ellipse. So here a small mistake it will be done in the uh, sentence. Yeah, cutting plane is inclined to the horizontal plane as well as inclined to the uh, vertical plane also. Okay, wow. Perpendicular to the vertical plane. Then the shape of the curve is called as ellipse. So I am clearly explained here. Some of the different examples are given. Very first, a tunnel. Okay, ellipse application. First diagram, a small representation is given here, a cartoon diagram. A red color man will saw the another man. So through the elliptical shape, the vision is how going to like this for the other person. Okay, then the tunnel shaped, elliptical tunnel shaped railway bridge construction, second image. Then on important figure is like a indoor stadium. Okay, indoor playground, elliptical shape indoor playground. Okay, these are all the practical examples of ellipse. Next, for parabolic curve. So when the cutting plane is inclined to the axis and is parallel to one of the generator line. Okay, so one of the generator line means I already say each and every degree the generating line is passing. Okay, that generating line will yeah, generating line is called as a I'm saying already for imaginary line. Okay, that imaginary line, you consider the cutting plane here parallel to that one. Okay, and also inclined to axis. So like this a shape like this point you have to be cut and remove the remaining portion means definitely you get a parabolic curve. Okay, so parabolic curve is a very important one for designing of headlights of car vehicles, maybe the truck vehicles. Okay, and then bridge construction, parabolic curves are very important. Here I'm showing you some practical examples of bridge construction, parabolic curve. Okay, next we move on to the hyperbolic curve. In hyperbolic curve, when the cutting plane is parallel to the axis of the cone, then the true shape of the section is rectangular hyperbola. Okay, parallel to the axis of the cone. So axis parallel you are given mean cutting plane, then the remaining portion will gives as a hyperbolic shape. For example, a practical explanation is given by here for chimney. This chimney is a very important one process for thermal power plants. Okay, in thermal power plants the exhaust gases will really remove through this chimney portions only. Okay, in that chimney portion will definitely followed by the path of hyperbola. Okay, because in this hyperbolic nature slight hyperbolic nature will induce the velocity of the output gas. Okay, that's why the chimney can be designed based on the parabolic style. Then one structural design in the foreign country is available example of here. Then light, all the lights are given for a shape of hyperbolic structure only. In a car or vehicles produces the light beams rays. You follow or look at the light beam shape, parabolic structure only. Okay, these are all the examples of hyperbola systems. Okay. Next, we move on to the construction of parabola, hyperbola, and ellipse. How we can go for construct the parabola, hyperbola, and ellipse? So before going to construction of parabola, hyperbola, ellipse, we first need to the eccentricity. So what is eccentricity? Okay, before going to the focus and directrix. So conic may be defined as the locus of a point moving in a plane in such a way that the ratio of its distance from fixed point called focus and a fixed straight line called as directrix. So fixed straight line, it is called as directrix line. Fixed point is called as focus. Then movable point is called as locus. So movable point, I mean that here the imaginary generating lines is called as movable point. Okay, or movable point or locus point. This locus point is moving point by point in the 360-degree, but the focus point is a cutting plane passes at the midpoint, I'm told already. So cutting plane passes midpoint of the axis. In that point is constant, but the cutting of new edges are different path. That is called it as locus point. But that axis is called it as yeah, practically I'm matching everything. Axis is called it as fixed straight line or directrix. Okay, so these are all the three important parameters are very important for draw or construct a ellipse, parabola, hyperbola. What is that? Fixed straight line, fixed point focus, then movable point locus. Okay, so a ratio can be maintained in this one. Okay, based on that ratio, we can simplify the three curves. Okay, uh, the ratio of shortest distance from the focus to the shortest distance from the directrix is called as eccentricity. So eccentricity is very important. That means the distance of moving point from the focus. Okay, that is called as I am told earlier shortest distance from the focus. Also the shortest distance from the directrix. Okay, so that shortest the ratio between the shortest distance of focus to the directrix is called it as eccentricity. The eccentricity value is very important. Every construction of ellipse, parabola, hyperbola, which is constant. How it will be differ means eccentricity less than one means ellipse. Eccentricity e equal to, okay, one means parabola. Eccentricity greater than one means hyperbola. These are all the three important constraints are useful for construction of ellipse, parabola, hyperbola curves. Okay, next, the entire explanation can be consolidated in this diagram. A cone section is given here in the left side of the figure. A triangle. In the triangle, the cutting plane passes perpendicular, inclined, parallel, and then inclined to the generating lines. Based on that, AA gives a shape of circle, BB gives a shape of ellipse, section CC gives a shape of parabola, section DD gives a section in the hyperbola. Okay, so these are all the uh, cumulative or collective information in this one diagram. Also, the right side of the diagram will covers the entire ellipse, parabola, hyperbolic structures. Okay, that's all about this diagram. It is very important one. Okay, now we move on to the problem construction of ellipse. How we can go for construct an ellipse. So ellipse construction is such a huge process, but it is understandable one. And once a practice of ellipse means parabola, hyperbola are easy. Followed by the parabola and hyperbola is very easy. So first of all, what is the given problem means? Draw an ellipse when the distance between the focus and directrix is 50 mm and the eccentricity is 2 by 3. Full stop. Also draw the tangent and normal of a curve. So how we can go for construct a ellipse first of all. So ellipse, before going to be construct the ellipse, first we have to be draw a one vertical line and followed by the one horizontal line. The vertical line is called it as fixed directrix line. Then horizontal line is a axis line of the ellipse. Okay, first I fixed the vertical line, then I fixed the horizontal axis line. Next I move on to the uh, vertex line. I want to be go for fix the vertex line. So vertex line here, V is representing as a vertex line. How I'm going to be fix that vertex line? So I have here the total distance of ellipse 35 mm from the focus to directrix. Okay, the eccentricity 3 by 4. So the total value is adding by numerator and denominator value 3 plus 4 equal to 7. So 7 equal parts I want to be fixed, sorry, 7 equal parts I want to be divided in the focus to the directrix point 35 mm. So each 5 mm I'm going to be splitting into this ellipse. So in eccentricity value 3 by 4. Okay, so here I'm fixing the point 3 from the directrix to the 1 2 and 3. The third point I'm fixing as a vertex 1. So because point from moving from the directrix to the focus. This is the definition of eccentricity. So from the directrix to the first point is known as vertex. Then from the shortest point from the directrix to the focus is called as another point. Okay, so first we fix vertex, then next we fix the focus. So third point is vertex, and then from the vertex to the focus point, followed by the vertex, we can fix the focus point also. From that vertex point I need to draw one vertical line. So I completely draw a one vertical line. After that I want to be fix the next two points p, p1, p2, p2 dash, p3, p3 dash. I want to be construct. How I can go for construct means I'm measuring the line from 1 to 1 dash. Through my compass, I measure the distance from 1 to 1 dash. Then I fix my compass in focus. Then first line I could have intersection mark. Then second I am going to be 2 to 2 dash I am measuring. Then fix my compass 2 to 2 dash I am intersect. Then 3 to 3 dash I measure. Then again I put my compass into the focus. Then 3 dash line I arced, cut into the arc. So like that I followed up to a maximum 11 or 12 points. Okay, either for above and below lines, both of lines I will be connected. Then all the intersection points I am going to be connected, and I formulated the ellipse line. So this is what I am going to be construct the ellipse. So practically it is very easy to construct. uh, in in conventional method we used to construct this in by using of a board by using of board, and then the remaining things are very easy to construct. So you're going to be practice well, and then this practice will improvise you to construct a diagram very easy and easy manner. So like that parabola and hyperbola we can go for construct. Next we move on to the parabola. Okay, so here parabola construction. Construct a parabola when the distance of the focus from the directrix is 50 mm. Draw tangent and normal curve at any point. Sorry for that. The before problem I cannot explain the tangent and the normal of the curve. Here you see, draw a line joining the point P and F. So all of you know point P and F. Okay, clearly indicate here. So F is known as a focus point. Draw a line FT perpendicular to the line PF. Okay, focus to the tangent is FT line. That perpendicular to the line of PF. Okay, then draw a line TPT which is tangent line. Okay, Here clearly TPT is the tangent line. Instead of this tangent line, we go for mark a perpendicular line, that is called it as perpendicular line. So this is called it as normal line. Okay, this is what the construction of tangent and normal of a given curve. So like that ellipse, sorry, like that the parabola, in that parabola construction, same as for fixing of directrix, same as fixing for vertex, same as fixing for focus. Here only the difference is the measurement of 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, and 4 to 4 dash are same. But the focus, when we are fixing a compass in focus and the respective lines we are marking, the lines are not closed well. Okay, lines are expanding a certain stage. Again, the continuously line can be enlarged. There is no contraction between the points of continuous points. Okay, this is the that is called it as parabola. How it will be happen means the new generating lines are parallel to the sorry, the cutting plane is parallel to the new generating lines. That's why it will be passes through the base of the line. Okay, so base of the cone. So no option for going for intersection of the new generating lines. That's why the every planes can be go for expanded always to be. Okay, this is what the construction of parabola. So now we go for hyperbola construction, the final one. Hyperbola. Hyperbola, already I'm saying the example of many construction paths. Okay. So in that hyperbolic curve, very first you fix the, already saying a hyperbola eccentricity value is less than 1. Okay. Sorry, greater than 1. So E equal to 3 by 2. So 3 by 2 means the 5 intersection points, you should be split into this 50 to 5 equal parts. Okay. So as per the given construction, first of all you draw a vertical line AB. Okay, then make a point C in the directrix. So C is the midpoint of the AB line. Next you construct draw a perpendicular line at C. That means that line is called it as axis line. Then the same procedure, the same steps followed by the followed to the ellipse and parabola, same like that. Then mark focus F on the axis from the directrix. Okay, because we know the directrix value is 50 mm. Divide CF into 5 equal parts because of eccentricity 3 by 2. Therefore, the 5 equal parts we are going to be splitting into that area. After that, vertex point we can fix it. Okay, well, from that vertex point, draw a line joining C and E and extend it. Okay, so another lines are extended respect as we need how much lines we need, that amount of lines are extended. Mark any point 1 on the axis. So like that 1 dash 2 dash 3 dash 4 dash lines are extended with the focus as a center and 1 dash as a radius. Cut the arc. Cut two arcs at the perpendicular line on both sides of the axis and name it is P1 and P2. So both sides, as usual, the paraboloid and hyperbola, sorry, as usual, parabola and ellipse we can follow. The same step we can follow. Either sides P1 and P2, 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 P2 dash, P3, P3 dash we can follow. But here also the line cannot be converged. It will be extended further cutting place. Okay, wow. So then finally you join all the curves and then you get a hyperbola curve. So this is the step we are going to be followed for construction of a hyperbolic curve. So hyperbola, parabola, and ellipse is all the constructions of everything. Okay, so our slideshow presentation we completed in this portion itself. Next we move on to the cycloidal curves. Right now we complete in this session we construction of ellipse, parabola and hyperbola. Okay, Thank you for watching of this video. You practice well for this diagrams in your conventional methods for using of scale pencils. Then you practice more well. Thank you everyone.